Yes, Mr. Saurabh, now you can share your screen.
Okay. Okay, my screen is visible.
Yeah, yes, yes.
So hello everyone, warm good afternoon to all. So I'm Saurabh Pawar, day scholar from NIT Bhopal, under guidance of Dr. Mithula Hirwal from NIT Bhopal. I am publishing this paper, Fusion Behavior Based RAW Algorithm, FABBRA, Applications over Constraint Design Problems in Engineering, paper ID 196.
Yes,
So these are
Saurabh, just a second, Mr. Saurabh, and I request all the presenters to limit your presentation within 10 minutes of slot, and I request all the session chairs to kindly fill the evaluation sheet provided. Uh, Thank you, sir.
okay. So these are the table contents, background, literature survey, research gaps, problem description, methodology, discussion results, and conclusion references. So towards the background, so we know that nature-inspired evolutionary computation includes the various algorithms like artificial bee colony optimization, gray wolf optimization, spider monkey optimization. So these insect-based or animal-based, all the algorithms comes under the swarm intelligence optimization, which is the branch of artificial intelligence. And the evolutionary algorithms, which mostly includes the algorithms which have the population-based criteria. So there is one more category called as a metaphor-less algorithms, which is not using the any animal or insect-based algorithms. These metaphor-less algorithms includes the algorithms called as a Jaya algorithm and Rao algorithm. So the Rao algorithm is one of Rao and Jaya. These are some parameter-less algorithms which does not need any parameter to tune before using these algorithms. So coming to the literature survey, so this first is a base paper. We have used that the Rao algorithm, 3 metaphor-less simple algorithms for solving optimization problem by the R.V. Rao sir. And this is a simple parameter-less optimization algorithms given by sir and using the randomness to calculate optimal value of any objective function. So before that, the Jaya algorithm was also there. TLBO algorithm was also there. So these are reference number 3 and 4 are some applications over the Rao algorithms, where the Rao algorithm has used for the problem solving in the real time. So there is one more algorithm called as a monkey behavior based algorithms. This is one paper number 5 is one of the reference for it. These are the algorithm where the behavior of monkey is studied and the various algorithms which is categorized using the monkey behavior are given in this paper, survey paper. One of the monkey behavior based algorithm is the spider monkey optimization algorithm. The spider monkey optimization algorithm and there are some research work is given in the paper number 6 by Agarwal V and others. The SMO is the spider monkey optimization algorithm, which is where the various real-time applications have this algorithm. Have also these applications are also there using the lib detection, using lib detection, lib disease detection is one of the example for the spider monkey optimization application. So there and the later on the the benchmarking functions are taken from these papers. So the problem's description is to develop a new fusion behavior based Rao algorithm, FABBRA, using the fusion social behavior of spider monkey or swarm optimization and metaphor-less Rao algorithm to solve the constraint, unconstrained, and the real-time optimization problems, including mechanical design problems. So this is the existing methodology. So towards the methodology, this is the existing Rao algorithm. So these are the 3 Rao algorithm equations given in the paper number 4. So Rao algorithm, this X new is a new candidate when we update. We use the X old, the older candidate plus random number. R is the random number into bracket the best candidate minus worst candidate. So let's focus on the one equation only. So new candidate is developed. New candidate is obtained in this way. So in the this is updated for the entire population. So coming towards the new methodology, in the proposed fusion behavior based Rao algorithm, we have done some modification in the existing methodology. So X new is updated in a such a way, X new is equal to X old, the earlier one candidate, plus a random number into X global best minus X local worst. So this local worst and the global best concept come from the fusion behavior of the spider monkey optimization algorithm. So what is exactly it? So in the spider monkey they live in the unite group and they split themselves whenever the food scarcity occur. So this process is called as a fission. The splitting of the population is called as a fission. And when they unite together in the evening, for the evening in the this evening there is a criteria for the uniting. So that this is called as a fission. This is a fission and fusion behavior based algorithm. So from that algorithm, we have we divide the population into the subpopulations, and the entire the global best is nothing but the best among the entire population, and the local worst is nothing but the worst from the subpopulation. So coming towards, so this in this way the entire earlier equations were updated, and so this is the flow chart we can say, or idea for the existing new algorithm methodology. So in the earlier approach, the population were not divided, but in this approach, the population is divided into the subpopulation. So where criteria is used as number of CPUs present in the. So in the future, we are planning for the parallelism or using high performance scientific computing to optimize. So entire population is divided into the subpopulations, and we find the local worst in the entire the subpopulations, and update the equations using this earlier any of the equation from the earlier equation, and we can get update the equations. So update the subpopulation one group with respect to the local worst from the subpopulation and the global best from the entire population using the Rao algorithm equations, updated Rao algorithm equations. And later on, the merging of population is done. This is a fusion. This is the splitting is the fusion, and we check whether the candidate is better or not. If the x dash solution is better than x, yes, then accept and replace the previous solution. Otherwise, they keep the previous solution until the termination criteria. We can say the number of iterations is a termination criteria. Till we not receive the exacting termination criteria, we'll go on for the iterations to get the optimal solution. So this is the proposed methodology. So coming toward the results and discussions. So the existing the proposed methodology is tested for 7 unconstrained problems where it has given a good results, and also along with that some constrained real-time problems, mechanical design problems. One of the it is a 3-bar truss design problem. So from paper number 12, it is the reference is taken from the Milimanjiri paper. So where the author had given the modeled 3-bar truss design problem. And so this is the example of constraint design problem. So when the results were obtained, so this is the result convergence graph of 3-bar truss problem. So if we see the algorithm is FABB array is the existing proposed algorithm, Jaya and Rao algorithm. So convergence is much earlier than as per the earlier approaches. So this is the improvement in the results by this proposed methodology. So towards the comparison of results, so allow not only the 3-bar truss, the 3-bar truss problem, PV design, pressure vessel design problem, cantilever beam problem were also tested. So these are the some code from used in the paper. So the existing methodology is tested for this, and if we see the fusion behavior based Rao algorithm, FABB array 1 and 3 had shown the good performance than the earlier algorithms. So CS is a cuckoo search, multiple optimizers, Jaya algorithm. So all these algorithms were taken from the references, and this is the results. So also Wilkinson test for the statistical result, the summary rank summary is given. So this has also given the good result. It has also shown that the FABB array 3 has a total 5 and FABB array 1 has a 7. Lower the rank, that means the algorithm has a better significance over the other algorithms. So in which also FABB array 1 and FABB array 3 had shown good performance. So towards the conclusion, so updated the earlier Rao equations to solve the modified, solve the optimization problems using fusion behavior SMO. So performance were improved by dividing the population and updating the equations. So computational experiment were involved for proposed methodology or some of the real-time design mechanical design problems. So in the future, the parallelism can be used. So parallelism where the use of n cores of the CPU independently for calculating the subpopulations to get an optimal solution much earlier. So if we are dividing the four subpopulation as of now by manually, but if you are using the particular processors, if a 4-processor machine is there, so independently dividing and updating the solution can be done by independent processors, so that high performance scientific computing can be used in the future for the proposed methodology. So these are some references for for this user for this PPT. So these are the references. So thank you so much all. Any questions?
Yes, any queries from the session chairs?
Yes, Saurav, correct? Saurav.
Yeah, Saurabh here. Yes, ma'am.
So good and very crispy presentation. So I think you are very stick on with the timing also, correct?
Yeah.
So like that only you prepared your slides also.
Yeah.
Overall good. So you are mainly solving the optimization things, correct?
Yes, ma'am.
Solving optimization problem. Uh, will you go to the objective slide?
Problem of description. Yeah, objectives.
Problem description. Okay. So is that this optimization problem is very specific to the behavior of this spider monkey spam optimization thing, or you can broaden the way also?
This is mainly on the RAW algorithm. We have only used the fission and fusion strategy from the spider monkey optimization, because spider monkey optimization algorithm is a parameter, is using some parameters, but the RAW algorithm is not using the parameters, any parameters.
And I'm asking in terms of scope, whether it's a very narrow scope or we can widen the scope also from
Yes,
this.
we can widen the scope. If we use the parallelism in the future,
Hmm.
so earlier approaches it takes a large amount of time to calculations. So if we use the parallelism in this in the proposed methodology, and we are working on it for parallelism work, so then the computational time is can be shortened. So this is the one of the benefit of this algorithm.
Okay, so that's why you mentioned future work with by using
Yeah,
correct?
any processors. Yeah.
Okay, so will you please give a short statement like what is it parameterless and mechanic design problem something? Yeah, mechanical design problem.
Okay. So parameterless is nothing but, if we see here, if any algorithm, R is nothing but a random number used from 0 to 1.
Hmm.
So this is the randomly directly taken from the any. If you say as a, let's consider example of the spider monkey only. The spider monkey optimization algorithm having some 4 parameters, number of monkeys, or some the perfusion rate 0.7. It is used in the that paper. So these particular parameters have need to be tuned before the problem starts. So this is the
Like that you
difference.
are proceeding, correct?
Yeah, so that we are not using any we are not tuning any particular parameter as per the earlier algorithms. RAW algorithm is not tuning any parameter. We are also not tuning the parameter.
Okay, what is that mechanical design problem? If there is, why you have specifically mentioned that word
Okay,
problem statement?
okay. These mechanical design problems, right?
Hmm.
Okay, so this proposed methodology is tested for unconstrained problems and the real-time optimization, including mechanical design problems. So mechanical design problems are nothing but from one of the paper I had referred, in which these 3 problems were given. So I have chosen these 3 problems having the already given the mathematical model of the objective function. So I have used that in this paper to check the performance of the proposed methodology. So I am included that in this objective.
So you are claiming it like mechanical design problem in line with the mathematical structure, correct?
Yeah. From this is the same mathematical structure we used.
Okay, got it. Because some terms are different in your way, so that's why I need a clarity.
Okay.
Go to that slide number 11.
Yeah.
Okay, so here in the X and Y side, right? So
Yeah.
you mentioned it's the best value. So best
Okay.
value for what?
Okay. So best value. So this is, if you see the 3-bar design problem for 3-bar trust problem. So 3-bar trust design problem have the best value, that is the minimum value is 263. Okay, so this is a 263.89 is the best value. So if we see from the y-axis, the best value is the starting phase. When the algorithm start, it is at higher range. So it is coming towards the minimum value, right? So
No, that
as
thing I
as
got
the
it.
iteration goes on.
That thing I got it. Whichever the thing you are climbing as a minimum, so that's why you mentioned it's the best value,
Yeah,
right?
minimum value is the best value.
But I can say that if technically if you put any words related to that algorithm and the y-axis, then it will be very good.
Okay.
Because you are proving it's the best value. I agree with that. So that's the main reason we are all of them are doing research to
Okay.
improving, increasing or decreasing. All these things are it's a default. So no need to mention it's the best value like that. Instead of that, put the parameters. What is the parameter you are considering here? According to the number of iteration, what is the calculation you are doing?
Number of these are the number of iterations, and this is the whenever this is the nothing but the best value, in the sense when this algorithm termination criteria is satisfied, we get the optimal value. So for the first iteration, what is the optimal value, second iteration, what is the optimal value, in this way. So for every iteration, whatever the optimal value.
According to your result, which parameter name you can, that is very suit for this y-axis. Okay. Just
Okay.
think about it.
Optimal value. Okay, I will think on that.
Value. You can use the best, you can use optimal, all these things are inbuilt, right? But which parameter for that you are increasing or decreasing, that parameter name you need to mention it there in the graph itself. Okay.
Okay.
And finally, your methodology success is good. That flow is good. So I need to appreciate that one also. And apart from that, it's good. Overall, it's good. Thank you. This is from my side.
Okay, thank you, ma'am.
Any other queries from the session chairs or? Shall I proceed for next paper?
Yes, you should proceed further in the second paper.
Okay, sir. Thank you, sir. We have second presentation for paper ID 302 will be delivered by Mrs. Divya Mohan.
Can I share my screen, sir?
Yes, I'm making you the co-host. Yes, now you can share your.
Flexible and I'm audible.
Yes, both okay.
Myself, Divya Mohan, research scholar from Amartya School of Engineering, Coimbatore. ID 302, vertical discrimination of expurgated hyperspectral image utilizing multiverse optimization. So my presentation includes the background, literature survey, proposed methodology, results in discussion, and the conclusion, also the reference part. So the background is hyperspectral imaging as a method for creating a spatial chart of spectral variation that can be used for a number of purposes. Due to the increase in the resolution ratio of hyperspectral images, many previously unsolvable problems, especially using multispectrum, can now be solved using this hyperspectral images. Hyperspectral images can capture more accurate spectral responses, which is one of its advantages, one of the best advantages of this hyperspectral imaging. This hyperspectral images have hundreds of bands, making them the best suited to track subtle variations in ground covers and their changes over time. So multiple spectral bands and vast volume data not only make the data acquisition and distribution impractical, the major problem is like it introduces image processing challenges. Hyperspectral imaging characteristics are difficult to obtain from small sets of labeled samples, placing training samples at the risk of being the overfit. Target detection is also one of the most challenging aspects of hyperspectral imaging due to its variability of target and the background spectra, which makes designing effectively hyperspectral image target detection algorithms very difficult. So going on to the literature survey part, the band selection is widely used to identify relevant bands for Landauer classification of hyperspectral images, and the combination of spectral and spatial information can improve the classification performance of hyperspectral images dramatically. Similarly, the fusion of spectral and spatial information, this should also improve the performance of band selection. In this article or in this paper, two semi-supervised wrapper-based spectral spatial band selection algorithms are proposed, and the local spatial smoothness of the hyperspectral imagery is used to improve the performance of this band selection also. So after that, the smile effect, which is a major problem in hyperspectral images, especially during the sensor side. So the smile effect implies a shift in wavelength, which is actually a type of distortion. Again, the sensors are currently acquiring a continuous stream of hyperspectral data, and many efficient unsupervised algorithms are required to analyze this great amount of data. And the identification of image N members is another crucial task, which is also tried in this paper. So the problem description is like to discriminate the hyperspectral image using multiverse optimization algorithm after doing the smile correction and also the end member extraction, and finally to identify the vegetation area. So my methodology includes taking a input hyperspectral image on any of the data sets. I have tried with 3 data sets, and after applying semi-supervised band selection technique to identify the bands having this smile effect, and also distortion problem. After correcting the smile effect using stabilized smile frown technique, I'm going for the end member extraction. It is used, it is done using volume shrunk pure pixel actualization method. After that, vegetation area is identified using multiverse optimization algorithm. So coming on to the explanation of block diagrams. First is a semi-supervised band selection technique. I have used the filter wrapper semi-supervised band selection technique, and this uses various factors like Bhattacharya distance, divergence technique, Jeffreys-Metzer distance, etc. Using these factors, I have done this band selection. After doing this band selection, what I have done is to identify the smile effect and also to eliminate the Hughes phenomenon. This Hughes phenomenon is nothing but several highly correlated and irrelevant information. So I have to remove this Hughes phenomenon. Using this band selection, I can remove this Hughes phenomenon to a limit. And after that, I try to identify the smile effect. That is a distortion effect in the hyperspectral images. And using stabilized smile frown technique, the smile effect in the hyperspectral image is minimized. And that is done using the spectral sharpening, which uses a spectral reflectance value to detect the smile affected signals, maximum and minimum noise fraction values. And this also to prevent the excessive spectral data. And next is end-member extraction. End-member extraction is an important process because to identify the exact exact target, I have used this end-member extraction that is carried out using volume shrunk pure pixel actualization method. After that, I have gone for this dimensionality reduction. And after dimensionality reduction, the final step is to identify, okay, before that I could explain the steps for that. The algorithm proceeds by generating a large number of dimensionality vectors or skewers to the data set. Every data point is projected onto each skewer along with its position as pointed out. As more squares are generated and number of times a given pixel is placed on this list, it's also tallied, and the pixel with the highest value is considered as the purest ones, and using this purity index, exact pure pixels, because we are giving more importance to the green pixels. And using this multiverse optimization, even if the image has been perfectly pre-processed, because we have done almost many processes for exactly identifying the end member and all. Even though all these steps have been done, a highly precise function extracted in the hyperspectral image, a single small pixel contains a high level detail because it's a hyperspectral image. As a result, optimizing the use of such or optimization, here comes a need of this optimization. As a result, this research incorporated a multiverse optimization algorithm. This employs a nature-inspired concept to work with extremely structured data and also to make the best of everything that's viable. So this is a final what I try to do to identify the vegetation part in the hyperspectral image. The data set, this is a vegetation detected area after the categorization, final categorization using multiverse optimization, and have just some performance evaluation also. So I have just calculated the computation time. So computation time for different data sets, Indian Pines, University of Pavia data set and Salinas data set, I have just computed the computation time and also calculated the accuracy for different computation times and just plotted it out. And next, as another method, I have just taken some papers and some methods were taken, similar categorization methods, segmentation methods were taken. And after that, along with this proposed method, I've compared it. There's a computation time for this proposed method, as the time required is very less to perform this proposed method. So as a conclusion side, this proposal eliminates the Hughes phenomenon, removes the difficulty. Hughes phenomenon is nothing but the different correlated information in a single pixel, removes the difficulties created by a lack of label data set. The smile effect is distortion due to smile effect can be minimized, and excessive spectrum data removal can be prevented, and also an optimized resource utilization is carried out. These are the references. And thank you so much.
Thank you, ma'am. Queries from the session chair? Any queries from the session chair?
Yes, so Divya Mohan.
Yes, ma'am.
Good afternoon.
Good afternoon, ma'am.
Ma'am, first of all, tell what is the scope of the research? I just confused with your entire slide. So you are using the methodology, all these things are okay. I agree with that, but mention what is the scope of this research?
Ma'am, this is to identify the vegetation area in a hyperspectral image, ma'am. So this I have performed for already available data sets. This can be done in any of the real-time data set also.
Yeah,
That means
that
we
is
can.
so that is the point actually. So you have completed all these things, whatever the things you result projected. So that is for already available data, correct?
Yeah, available data, but actually these data are not radiometrically corrected. So when I perform this, after this radiometric correction of smile effect and in member extraction and all, I can clearly point out the vegetation area.
Okay. So also you are using that multiverse optimization.
Yes, ma'am.
Okay. Is that your propose, correct?
Actually, multiverse optimization, actually, I am doing it 3 or 4 different things, ma'am. First of all, to eliminate the Hughes phenomenon, because so many correlated informations are there in a hyperspectral image, because it has got more than 220 bands. So, first of all, I'm doing band selection, because I just need to eliminate the distortions affected in the hyperspectral images. For that, this band selection, I have to exactly identify the smile affected bands. For that, I'm doing the band selection. After band selection, the smile using the stabilized smile correction technique, I'm correcting the smile effect. And after that, to exactly identify this vegetation area, I have to point out, I have to go into the image in detail. For that, I'm going for the member extraction. After in member extraction, finally, as a final step only, I'm applying this optimization technique to just exactly identify the greenish region.
Okay. In that band selection, if that is any mathematical model you have already developed, or still you are working on with the existing concepts?
No, ma'am, I'm working on with the band selection, because I have just applied a semi-supervised band selection technique, because already some of the data are labeled, and using that only I've tried with the semi-supervised band selection technique. I'm working detailed on this model just to identify exact band selection technique to get the exact bands where the distortion is really affected.
Okay, so because that band selection is very, very important in your research work, I can say
Yes,
it's
ma'am.
the base of the work, right?
Yes, ma'am. Yes, ma'am.
That case, so just try to develop a mathematical model related to that. Don't stick on with the existing things.
Okay, ma'am.
Okay.
Okay, ma'am.
Okay, Divya, good presentation.
Thank you so much, ma'am.
Thank you. So this is from my side, sir. Thank you.
Thank you, ma'am. Any other queries from the session chair? May I proceed for next paper presentation?
Yes, yes, please go.
Thank you, sir. We have next paper to be presented is paper ID 337 will be presented by Mr. Vamsi Krishna.
Yeah, good afternoon, everybody.
Good
I think
afternoon.
I'll share.
Yes, Mr. Vamsi, you can share your screen now.
So may I know what is the paper ID for this?
Paper ID is 337, ma'am.
Yeah, can you see it?
Yes, yes, you are audible, and
Okay.
please start the presentation.
Okay. Good afternoon, session chairs and organizing committee. I'm Vamsi Krishna. I'm from Amrita School of Engineering, Amritapuri, and this work has been guided by Dr. Jor Pujar. Okay, yeah, these are the table of contents. So this is the actual problem that we are trying to solve. But before that, as a small motivation, I'd just like to point out that more than 30% of deaths in India are due to air pollution, and we also hit an all-time high in carbon emissions from India in 2019, some thousands of tons of carbon emissions. So it's an actually very relevant problem to work on this day and age. Now, with that, I'll start the problem. So, vehicle routing problem is where you will have a set of vehicles, and you'll have some number of customers, and they will be demanding something. So you'll have to either pick up from them or deliver to them some good or service. And at the end of it, all the customers are need to be serviced. So their demands need to be met. Capacitated vehicle routing problem is a more constrained version of the vehicle routing problem, where we'll also take into account the capacities of the vehicles. The vehicle routing problem assumes that the capacity of the vehicle is infinite, but in a more realistic case, capacitated vehicle routing problem also models the capacity of the vehicle, where there's only a limited capacity, and after that, after it uses up the capacity, it needs to go back to the depot and refill or deliver whatever, and then come back to serving the customers again. So this is what a solved vehicle routing problem with capacities looks like. Each customer will have some demand, and these are the customers with the numbered circles, and the 0 is the depot, and every vehicle starts and ends its journey at the depot. So in this particular route, this vehicle is going to customer 7, whose demand is 8, and then coming to customer 13, whose demand is 4, coming to customer 12, whose demand is 2, and so on, and completes the route and gets back to the depot. Yeah, so our end goal is to minimize the total distance traveled by all the vehicles. Now the literature survey. Firstly, in the initial test, before this machine learning boom and all happened, so to speak, there were good heuristics and meta heuristics to solve these kinds of combinatorial optimization problems. But what happens is, when we are trying to come up with a solution in very little time, machine learning, the pre-trained models come in handy, because the heuristics or meta heuristics are only as good as the actual formula that one comes up with, whereas these machine learning models need no hand tuning in the formula department. So, but these need to be trained in the hyperparameter. So starting off, there is a basic sequence to sequence model. The whole idea here is you'll give it a input sequence with a fixed length, and you'll get the output sequence with a fixed length, and it can be modeled using RNN, where the RNN encodes the input sequence, and we'll get a fixed length vector, and this is the actual essence or representation of the entire input sequence, and then we'll decode it using another RNN, producing the actual output. Yeah, and the way this RNN decoder RNN outputs is based on some probability that will be generated from this fixed length vector. As I talked, one limitation is it requires a fixed length sequence. So let's say we train the model for 20 customer nodes. When another customer joins the list, the model needs to be retrained. So that's the issue with this. Then pointer network came up, where the output sequence is each of the node in the output sequence points to a part of the input sequence, giving it some kind of attention, so to speak, where this particular output is due to that particular input sequence. Then moving on from the pointer network, there is something called as Markov decision process, where only the present can determine the future and not the past actions. This makes it really easy for the vehicle routing problem to be solved by a reinforcement learning model, where the agent keeps on interacting with the environment. Here the environment is the set of customer nodes, and the interactions are serving them. And based on these interactions, the environment gives some kind of reward to the RL agent. And this reward, it can be easily modeled because reward is just the inverse of the distance traveled by the particular vehicle to get there. So the more distance traveled, the less reward is there. Finally, this is the vanilla RL model, now we have a look at the dynamic attention model, which is a step above the reinforcement learning model, because what it does is it has multiple layers in its encoder. So whenever a partial solution is generated, the remaining set of customers that are to be serviced has obviously a different structure than the initial problem. So it reencodes the entire current problem into the node embedding, and then it tries to decode the solution. Whereas the decoder is pretty much the same to the vanilla. The main difference is the encoder. And multi-head attention is the main important part here in the encoder, where it takes in multiple inputs called as value key query. These are from the natural language processing domain, these terms. And it parallelly computes with all the 8 heads. The head is what we call this one particular thing, and there are in parallel we have some n number of heads. And after this attention mechanism, all the learnings from the heads are concatenated and projected back onto the embedding space. So before we dive into the equation, just for some intuition, what we understand here is the multi-heads in a particular layer of the multi-head attention model. These multi-heads are good at capturing the local structure of the problem, whereas the multiple layers in the multi-head attention are good at refining those understandings. Now we have looked at some equations. This is the query at the ith node in the nth head at the lth layer. Same is the case with the key and the value. We generate these from the previous layer's node embedding L-1. And after these are generated, we match the query with the key and we generate what's called a compatibility. This is the compatibility of the ith node with the jth node. So the assumption is that vehicle is currently at the ith node and it wants to go to jth node. It before going to that, it checks out the actual possibility and makes a decision upon that. And from that, a softmax function is applied, and we get the attention. These are the actual attentions. And after we get the actual attentions, those are multiplied with the values, and with some feed forward layer after this, the entire learning is projected back onto the embedding space. This is where the probabilities are generated. So now we have a look at different attention, different costs of the various heads in the attention. We could only train and for the models with only one layer because it's highly hardware intensive. And for the smaller number of customers, that is the small problem instance, we can see that 8 heads, that is the multi-head model, clearly outperforms the single head and 4 head model. And also the same behavior is to be expected with the bigger data sets, but we could not train them to that extent. But it clearly shows the improvement over the 4 heads cost. These are the optimal values of the standard data. Now to conclude, all these simulations were run on Google's Colab notebooks, and what we mean of small instance is 20 to 30 customer nodes, and medium is about 50 customer nodes. Actually, we planned on running with large customer nodes, 100 or 200 nodes, but it takes a really long time to even complete one epoch. So these are the nodes that we tested. So clearly, we can see that in the smaller number of customer instances, 8 heads outperforms the single head and multi-head costs. But in the bigger instance case, it needs more training, is what we understand. And I'd like to also call out the scope of the models here. It can easily be extended to other and more complicated, more constrained versions of the vehicle routing problem, such as vehicle routing problem with time windows and capacities. In the time windows case, it can be extended just by redefining the reward function. So the more time the vehicle takes to get to the node, the less reward it gets. And thanks to the pointer network formulation of the problem, we also can easily extend it to split delivery problem, wherein there is multiple, this possibility is allowed, wherein multiple vehicles can go to a single customer and serve partial demands, so that the entire demand is fulfilled by some vehicles that go to that particular. So these are some of the references and links are provided. With this, I'd like to end my presentation. And once again, thank the MISP, and I'm open to questions.
Vamsi,
Yeah, I'm sorry, I stopped sharing my screen. Now I started. Yeah, please go.
it's Dr. Londe. I want to ask you one thing, reinforcement learning.
Yeah.
What do you understand by reinforcement learning?
Yeah. As per my understanding, reinforcement learning is where the environment itself provides the learning to the agent by giving certain reward. So
Rewards, right?
Yeah.
Rewards. And
Yeah,
we say that it is a reward based learning.
Yes.
So in your case, while detecting the nodes, what will be the rewards? How you are deciding that?
Yeah, in our case, vehicle routing problem case, the reward is basically the inverse of the distance traveled to get to that particular node. So the more distance it travels, the less reward it gets.
Okay, and in that learning, why this attention mechanism will help you?
Yeah, in vanilla reinforcement learning, what happens is it fails to capture some of the complicated neighborhoods in the complicated neighborhood structures in the problem, but multiple heads and multiple layers can help in the following way. Multiple heads can actually learn from each of the individual sub neighborhoods, and multiple layers can aggregate those learnings and refine them so that the encodings of the nodes are getting better after each layer.
No, I have a feeling here that even your model without attention mechanism could also give you some similar results, because you are further writing here that tuning of hyperparameters will get you the better results further.
Yeah.
Okay, but it doesn't happen. Means it is not successful every time.
Yeah.
You could have done some comparison here with and without attention. That
Yeah,
would
one
have
head.
that
Yeah,
would have given you an understanding.
Yeah, I understand
Yes.
your question. You're saying that why the unnecessary complexity in the architecture, we can just go with the reinforcement learning basic model, right?
Right.
Yeah, that's what the one head attention does. It's basically vanilla reinforcement learning because there's only one head and one layer. So that's what the basic.
No, one, I'm saying without zero head.
No, the zero head is nothing but there won't be any architecture. One head is basically not multi-head attention. Multi-head attention, the whole proposition is you'll have parallel learnings within the neighborhood and we'll aggregate them. There's only one head. We just
After them. Right.
Yeah.
Okay. Thank you, Vamsi.
Yeah, no issue.
Vamsi, can you go to your references?
Yeah.
So do you think that references can be written in this way?
Actually, I wanted to link it, so I've only pasted the title and the link is in there.
So it is very hard to correlate that in your literature review and all those. You are writing the references with the numbers, 50,
Yeah.
34, 24. And here, can you show me which one is the 50?
Yeah, if you give me a minute, I'll just bring up the PDF there. And
From your slides.
oh, from the slides, it's actually not.
So what is the meaning of the references then?
Yeah, it could have been better. I mean, what I thought is linking it will be better, so to refer it.
Okay, thank you.
Shall I proceed to next presentation, sir? Ma'am?
Yes, yes, please go ahead.
Yes,
The
sir,
next
proceed.
presentation, thank you, ma'am. The next presentation is for paper ID 372 and will be presented by Mr. Lakshmikant.
Yes, sir, I'm here.
Yes.
Am I audible?
Yes, you are audible. I'm just making you the co-host so that you can share your screen. Yes, now you can share your screen and start the presentation.
Just a second, sir.
Yes, it is visible.
Okay. Okay. Good day, everyone. This is Lakshmikant. The work I'm going to present today is QKPIC, a socio-inspired algorithm for solution of large-scale quadratic knapsack problems. So this research is conducted under Professor C. Vasanta Lakshmi and Professor C. Patwardhan at Dayalbagh Educational Institute, Agra. I thank the editors and the organizing committee of this conference for the article acceptance and this opportunity to present my work here. Through this presentation, I'll walk through these topics. And let's just start with the implicit computative algorithm. It is a socio-politically inspired evolutionary algorithm widely studied and applied to solve engineering search and optimization problems. This algorithm mimics imperialism and imperialistic competition processes seen in the real world, as we already have seen the British over Indians, as the empires try to overcome more and more colonies under their possession, and their attempts to transform those colonies like themselves. Like British build railway lines here, and other they try to impose themselves on us. Obviously for their benefit under two processes called as assimilation and revolution that we do. Revolution is the part the colonies do, and the assimilation is the part the imperialists do. So talking about the socio-inspired evolutionary algorithms or socio-inspired meta-heuristics, these are the algorithms inspired by human social phenomena like interaction or behavioral actions in humans like we do. I would like to convey one more thing that Saurabh M. Pawar just presented. Jaya and Rao or TLVO algorithms are the part of socio-inspired algorithms because they, in some way, they mimic the behavior seen in the humans rather than the animal or the insects or fishes. So ICA, the implicit competitive algorithm, is designed and applied to solve continuous optimization problems. However, some optimization problems, combinatorial optimization problems, are binary in nature. Sorry. For this, several attempts have been made in the literature to propose discrete versions of ICA because these problems are in binary nature. So discrete binary ICA, discrete ICA, modified ICA, binary ICA are some of the endeavors in this way. So talking about these, DVICA uses a two-point crossover as a simulation, and DICA and MICA use one-point crossover and are primarily utilized for ordering problems. While BICA, the latest one, uses 9 transfer functions in assimilation operation. And the author of the BICA, Mirosini and others, in 2017 proved that BICA outperforms DVICA on knapsack problems. So however, there is some paucity of true binary versions of ICA because they are using a two-point crossover from genetic algorithms, crossover from them again, and 9 transfer functions are just a random idea they are just putting into this. So in this work, we have proposed such an algorithm and verified its superiority over other binary ICs. We can say a true binary ICA. So problem chosen to demonstrate the applicability of our algorithm is quadratic knapsack problem, shortly known as QKP. It is an NP-hard combinatorial optimization problem. In quadratic knapsack problem, a set of items is given, each with a weight, a value, and an extra profit that can be earned if a pair of items is selected. The objective of QKP is to search for a subset of items that maximizes the overall sum of values, individual values of the items and their corresponding pair values. And at the same time, the sum of their weights does not exceed the knapsack capacity C. So QKP can be understood with an example of a thief who broke into a jewelry center and tried to grab only the items maximizing his profit from this robbery. So for instance, he is thinking about stealing a necklace costing 20K and an earring set costing 5K, while the complete necklace and earring set is 35K. His additional profit on taking the complete set is 35 minus 25, that's a total of 10K. So the question is, should he take the complete set or just one item from this? At the same point, we have to remember that he must choose the items wisely, as there is a weight constraint that he can carry, that he can put on his back or something called the knapsack capacity. Here, the selection of these items can be either 0 or 1, representing exclusion or selection of the items in the knapsack. The hardness of QKP can be understood from the fact that even for 1,000 items, the input or matrix size is 1 million, and for 2,000 items, it becomes 4 million. Apart from the, lastly, I told imaginary example of robbing a jewelry center, QKP has been applied in the fields of finance, cluster analysis, click problem, comparative chaining, and others. And these are some exact algorithms and some meta heuristics and heuristics applied to solve QKP. In this work, a binary version of ICA is proposed and demonstrated to solve QKP. To understand the proposed algorithm, we should understand what ICA is. So here's a pseudocode of ICA. ICA is a population-based guided random search algorithm. Hence, in ICA, a population of countries is generated initially, each representing one solution in the solution space. These countries form some empires, with some elitist countries serving as imperialist, and the remaining countries are assigned to these imperialists and are called colonies of so formed empires. So in this picture, colonies are represented as circles and imperialists are represented as stars. The same colored circles and stars belong to one empire. Talking about assimilation and revolution processes, they are used to improve the colonies in an empire by moving them toward the imperialist. So the difference between revolution and assimilation is that in revolution, colonies move with some deviation in the direction of imperialist rather than going directly in that direction. So after these processes, if a colony becomes better than its imperialist in terms of fitness or its cost, their roles are exchanged. And after that, imperialistic competition makes empires fight for colonies from weaker empires. And the empires with no colonies after the imperialistic competition are collapsed to some stronger empires. This moving and competition are repeated till only one empire remains, which is a termination condition for ICA. Bika is a binary version of ICA proposed by Mirosini and others in 2017. It uses these tabulated 9 transfer functions for binary assimilation. These functions actually convert the distance between a colony and its imperialist into a probability value. The colonies move towards their imperialist by changing zeros and ones in their solution representation according to the probability value generated by these functions. For the first 4 transfer functions, equation 1, and for remaining transfer functions, equation 2 is utilized according to Bika to update the colony positions. Here, x, I, t represents ith bit of a colony or country at time t. The algorithm we devised for solving large-scale QKP instances is dubbed as QKP ICA. In QKPIC, assimilation is performed as follows. Firstly, Hamming distance between the MP list and the corresponding colonies are calculated, and then the moving bits M for a colony with the Hamming distance D is calculated using a uniform integer uniform distribution function U. So out of the total D different bits, M bits are chosen randomly, and such selected bits are copied from MP list to the corresponding bits in the colony.
Sorry to interrupt you, Mr. Lakshmikant. I request you to kindly summarize the things. We are running short of time.
Okay, I'll be a little faster then.
Okay, thank you.
Coming to the results, in this study, BICA and QKP-ICA was tested on QKP instances of 1,000 and 2,000 objects. And we found that, let me talk about the parameters. The parameters are used from the Mir-Hosseini and others, although what we experienced with the experimental work, that the values for gamma and chi are the way high for BICA. So we just use the BICA's values here, but we suggest that the values could be a little lesser, because gamma actually represents the revolution rate. And one more thing, in our proposed algorithm, the value of beta tablet, the assimilation rate is not required. This is a parametric improvement in our work over BICA and other ICs. So we found that QKP provided the near optimal solution with a maximum of 0.32% gap on instances of size 1,000, and a maximum of 0.09% gap on instances of size 2,000. To verify this, we also performed Wilcoxon sign rank test, which is actually preferred for the meta heuristics to compare their performances. So these results can be verified visually in these graphical forms. Blue bar representing the best known solution for an problem instance, and brown bar represents best solution found using any version of BICA. Actually, BICA has 9 versions because of those 9 transfer functions, and the green bar represents our algorithm QKP-ICA. So I conclude this presentation with these remarks. So we proposed an advanced binary version of ICA, dubbed as QKP-ICA, to solve the large-scale QKP instances of sizes 1,000 and 2,000. For this, we devised a new assimilation process. The results show that QKP-ICA outperforms each version of BICA by a large margin. And to verify these results, a non-parametric statistical test, Wilcoxon sign rank test, was performed, which shows the superiority of QKP-ICA over BICA even on a significant level of 1%. And the structure of QKP-ICA is proposed in such a way that it can be easily adapted to other hard combinatorial optimization problems. Here is an alphabetical order list of some prominent references we cited in this work. Thank you. And thanks for your kind of attention. Now you are open to questions. Thanks.
Okay, so Lakshmikant, correct?
Yes, ma'am.
Yes, so overall it's a good presentation from your side. So many things, so many technical contents we can see from your research itself. But I'm having a very basic question in line with your problem statement only. You can consider it's a basic thing, right?
Okay, ma'am.
So you are mentioning it's a quadratic knapsack problem, correct?
Yes, ma'am.
So normally if it is a knapsack problem, I don't know whether if you are purely on computer science background. So normally we can implement it by using dynamic or greedy or some other approaches only, right? So
yes,
which particular concept you are climbing, whether it's go under dynamic or whether it's go under greedy to find out the best solution like that?
No, ma'am. Actually, hello.
Yes.
Yeah, ma'am. These are the algorithm we devised. It's meta heuristics actually. So talking about evolutionary algorithm and swarm intelligence algorithm, there is a new dynamics that is going to be, that is improved, that is evolved past 2 to 3 decades. It is called it is called socio-inspired evolutionary algorithm. So basic is the idea from social inspired evolutionary uses is the inspiration from human social phenomena. Like we are talking, we are teaching. Like TLBO is an algorithm which uses the idea between the communication between the teacher and the student, how they improve their results, how they learn. So the basic is we are just following the we are just mimicking the phenomena seen in human societies.
Okay, so by referring all these things you are doing, I agree with that. It's okay. The next very simple question. In between your problem statement or somewhere you mention about related to the knapsack problem like extra profit, right?
Yes, ma'am.
Normally we can say it's a cost. It means that it's an individual product profit. That is also there in your slide. Why you're saying it's extra profit?
Yes, ma'am. Actually, in a quadratic knapsack problem, when we select two items, the pair gives some extra benefit. I gave an example of grabbing the necklace and the earring set, while the both are of less.
Don't claim it's an extra. It means that whichever the item you are selecting as a combination,
Yep.
so the cost value just you are combining and you are telling that, okay, this is a profit for that particular person, right? So if you are using the word extra, so it means that you need to prove which one you are saying it's an extra first of all. It's not
Actually,
like
ma'am.
combining two things, getting the value, it's not an extra, right?
Yes, ma'am. Actually, what I mean by quadratic is there is a n by n matrix. So choosing an item I and choosing an item J also gives a corresponding Ij, Aij, or say Pij value. So their corresponding values are there, but when we select one value, one item with another item, there is some extra benefit.
Okay,
So
so
that's why I'm saying their corresponding values,
we
their
are saying
corresponding values.
extra, correct?
Sorry, ma'am, I couldn't hear you.
Yeah, selecting items from that ith and jth part. So you are saying it's extra profit, correct?
Yes, the pair values, the item pair values, extra values.
Okay.
Okay. Thank you,
Okay,
ma'am.
Srikanth, thank you. This is from my side.
Okay.
Okay, good. Once again, it's a good presentation.
Thanks for feedback, ma'am.
Thank you.
Thanks again.
Shall I proceed for next presentations?
Yes, please go ahead.
The next we have paper ID 431 will be presented by Mr. Arun Kumar. Yes, Mr. Arun Kumar.
Yes, good afternoon, sir. May I
Please share your
screen,
screen.
sir? Okay.
Please share your screen.
It is visible, sir.
Yes, yes, visible and you are audible. Please continue.
Good afternoon to all the session chairs. My name is Arun Kumar, and my co-author is Dr. Anil Kumar and Dr. Amit Vishwakarma from PDPM IITDM Jabalpur. My topic of presentation is multi-level crop image segmentation using Firefly algorithm and recursive minimum cross entropy. These are the table of content, background, literature survey, problem descriptions, methodology, result and discussion, conclusion and future scope, references. Image segmentation is the pre-processing steps in computer vision. Then why multi-level thresholding of crop images is required? The crop images that are having broad intensity range of color and their background is very, very complex. That's why the multi-level thresholding of crop images is a very challenging task. In the initial days, there are various issues in crops and they are resolved by the agriculture expert. But nowadays, by using technology, the farmers can prevent a big losses and they are able to predict about their products in many ways, such as They can find out the conditions of plant health. They'll find out the disease related to the crops, ripeness and non-ripeness status. So in last 2 decades, their thresholding, that means the pixel based segmentation of crop images that are highly observed. Thresholding is the basic step for segmentations of any images. They are categorized into 2 parts: bi-level thresholding and multi-level thresholding. By the use of single threshold value T1, that clearly shown in equation 1, single threshold value T1 that can split the images into 2 parts. That first class, that is C0, and second one is C1. In multi-level thresholding, more than two value of threshold, they can categorize the image into multiple parts, like that are used in equation 2, T1, T2, T3, and Tm. M number of threshold, they can categorize the image into M plus 1 part. Now come to the literature survey. That efficient method for multi-level color image thresholding using cuckoo search algorithm based on minimum cross entropy. In this paper, they have used the method that is minimum cross entropy, and the objective, they have used the 3 objective functions, that is ORSU method, T-SALI method, and the algorithm that is used as a cuckoo search algorithm. And cuckoo search algorithm that is used to minimize the multi-level minimum cross entropy. And their results is in terms of fidelity parameter, that is peak signal to noise ratio, PSNR, MSE, SSIM, and FSIM. Second one is the Renyi entropy and BAT algorithm based color image multi-level thresholding. In this method, they have used BAT algorithm as a Renyi entropy, and they have used the objective functions Renyi and ORSU. For comparison, Renyi and ORSU that has been compared, and in this paper, ORSU give the better result with respect to Renyi. The drawback, it suffer the lack of accuracy when it is used for multi-level thresholding. That means,
Arun,
yes, sir.
Sorry to interrupt you, but can you make the full slide?
Okay. Sir, it is visible, sir?
Yeah, now it is visible.
Okay. In third one, they have used the hyper-heuristic method for multi-level thresholding of image segmentations. They have used the hyper-heuristic method for each iteration and determine the optimum execution sequence related to the meta-heuristic algorithm, and they provide the optimal solutions. A quantitative analysis for lower and upper level of thresholding with ORSU as an objective functions. In this paper, single objective functions ORSU has used, and they try to find out the lower and upper level of thresholding, and result has been compared in terms of PSNR, SSIM, and CPU time. In future, it can be used as a multi-objective functions. In fourth one, fusion-based contextually selected 3D ORSU thresholding for image segmentations. In this paper, 3D ORSU based energy has been used for local contrast, based on local contrast method for efficient multi-level thresholding. This also, they also conclude their parameter in terms of PSNR, MSE, SSIM, and FSIM. In next, okay, image segmentation with Kapoor ORSU and minimum cross entropy based multi-level thresholding added with cuckoo search algorithm. In this paper, again, cuckoo search algorithm is applied to minimize the multi-level minimum cross entropy.
Kumar?
Yes, ma'am.
Yeah, sorry to disturb you. So instead of spending this lot more time in the literature survey part,
yes, ma'am,
go to the methodology, problem statements.
Yes, ma'am. So based on this literature survey, we found that multi-level thresholding of an image is an important issue, and when we are going to multi-level thresholding, the computational complexity is a biggest issue. when the number of thresholding increases. So that's why we have used such a efficient algorithm. So efficient algorithm with appropriate objective functions to approach the more segmentation result. We can also find out hybrid based algorithm, means one algorithm can be combined with other to find out the best segmented result. These are the methodology. Kulbach had introduced the concept of cross entropy, and these are formula that are described in equation number 3. Based on this equation, they find out the optimal threshold value by minimizing the equation number 4. Assume we have a crop images that is I, and L is the gray number, gray label, R number of threshold that are required to partition the image into R plus 1 classes. So these are the formulation, that is equation number 5, which is the simplified form of equation number 3. Equation number 3, we have the color images. That's why we have the color images. That's why this process is this process has been taken thrice. So in our paper, to increase the accuracy of segmented image, our objective function, that is the recursive minimum cross entropy, that is described in equation 5, that is incorporated with Firefly algorithm. These are the basic steps to find the optimal threshold value. Steps 1, first initialize the Firefly algorithm. Again, then we have to assign the dimension of problem and minimize the objective function using equation 5. We have import the images and obtain the histogram of each color component like red, green, and blue. Then we have input the Firefly algorithm parameter and specify the lower and upper boundaries. Lower boundary, that is 0, and upper boundary, that is 255. If the maximum iteration is reached, then stop the searching and again and obtain the optimal threshold value. Otherwise, go to the step number 4. Then evaluate the segmented image based on optimal threshold value. These are the result and discussion sections. The proposed method have been evaluated using 10 complex background complex images that are taken from reference number 12. The 4 important performance indicator parameter, PSNR, MSC, SSIM, and FSIM, that are described in next slide, that has been used to compare the outcomes. So based on this observation, the parameter value, they are selected in table 1. That is the wind repin optimization, and second one is Firefly algorithm. In Firefly algorithm, the total iteration is taken 300. The population size is 20. Alpha, beta, and gamma, that should be alpha equal to 0.001. So alpha is the random value that comes between 0 and 1. Beta is the attractiveness, and gamma is the coefficient of light absorptions. In wind ribbon optimization, the population size is 20. Total iteration 300. RT coefficient 0.3. Correlation coefficient 0.4. Velocity limit 0.3. Constant in update equation 0.4, and gravitational constant 0.2. In our experiment, we have done the 30 trial to avoid the discrepancy, any discrepancy, and best result I have selected.
Mr. Arun, sorry
Yes,
to interrupt
yes.
you. Please try to
Yes.
summarize it fast.
Yes, sir.
We are running short of time. Thank you.
Yes, sir. Yes, sir. So come to the slide number 11, that is the result and discussions part. We have summarized the PSNR, MSC, SSIM, and FSIM value from 6 to 9. These are the result and discussion sections. The proposed method, Firefly algorithm, that is compared with wind repin optimizations, and they are in tabular form. A, B, C, D, E to J, that are used for 10 complex background crop images, and summarized in terms of PSNR, MSC, SSIM, FSIM. We can see clearly from the average value in next slide. Next slide. These are the second level. These are the level 5. These are the level 8, and these are the level 16. We clearly see that the PSNR value that are for lower level, that are comparable, but for higher level, that's FFA gives better result. In terms of MSE mean square error, the for all the label it comes down. That means lower value of SSIM and FSIM. In both the cases, FA gives a Firefly algorithm is better than the wind-driven optimizations. So the accuracy of proposed method that are tested and compared with wind-driven optimizations, and we see that Firefly algorithms, the quantitative analysis of Firefly algorithm that is based with respect to wind-driven optimizations. Now go to the conclusion part. Firefly-based multi-level thresholding efficiently segment the complex background crop images, and for lower level of thresholding, it will be comparable. But for higher level of thresholding, a Firefly algorithm gives better result in comparison to wind-driven optimizations. The promising result of proposed method, it can be applied in different field of image processing, and in future we have used the enhanced FFA can be enhanced FFA can be used for multi-level thresholding of crop images. And proposed method will improve using 2D histogram method. These are the references. Thank you so much.
So Arun,
yes, sir.
I have one question that you have presented a image segmentation problem, but you have not presented any qualitative result.
Yes, sir.
Why?
Sir, I have not presented due to the less. I have thinking ki only for 10 slides is sufficient.
So I don't think
I'm sorry, I have not completed.
1 or 2 slides. Yeah, please go ahead.
Sir, I have not concluded in this qualitative results, but in paper I have concluded.
So what are the other measures which you can use for the similarity measures?
Similarity measures, I have used the SSIM in this slide. Structural similarity index.
So do you know any other quality measures which can be used in place of SSIM?
Sir, SSIM and FSIM, these two measures the quality. SSIM based on the structural similarity, and FSIM that is based on the features. And accuracy that has been measured using PSNR MSE value. Better the PSNR value, accuracy will be better, and lower the MSE value tends towards 0, that will be shows the better segmented result.
Okay.
Arun, I have one question to you. Arun.
Yes, sir. Yes, sir.
See, already the deep learning algorithms are being used for the segmentation work, like UNet and all.
Yes, sir.
And they are so successful with the raw data, no pre-processing is required, no features extraction is there, no selection is there. Then why to spend so much efforts on developing these algorithms? What you have done?
Sir, actually I have not done on this data, that is USNet and machine learning. Based on the previous literature survey, I have found that the multi-level thresholding of crop images, multi-level thresholding is the basic issue for the complex background crop images. So I have applied this algorithms for these crop images.
Well, you should think about comparing your results with some of the deep learning segmentation method. Okay, then you will be able to understand and how much efforts may be reduced. Okay, I'm not sure. Okay. Anyways, thank you, Arun.
Thank you so much for your suggestion, sir.
Thank you. Any other queries from session chair? Okay. On behalf of NIT Raipur and organizing committee of the conference, I thank you all for sparing valuable time. I thank you all the session chairs for providing valuable insight to the authors. And it is kindly requested from the session chairs to fill the evaluation sheet so that the best paper award can be decided and finalized. Thank you, sir. Thank you very much. Thank you, ma'am, for being available in this particular session. Thank you.
Thank you, sir.
Thank you all.
Thank you. Thank you.
Thank you.